Thank you very much. I'm very happy to be here. Can you guys, is it picking up? Okay, great. So what I'll plan on doing is talking for just a little bit about this field that some of you may have heard about called evolutionary psychology. It's a study of applying Darwinian principles to human, mostly to human, psychology. And I understand we have a little more time afterwards. I'm happy to, if you're welcome to interrupt me as I move along. It's not going to, I'm fine with that. But then there'll be some time afterwards where I'm happy to take any questions, any suggestions or comments or disagreements. I'm very happy to do that. Well, thank you again. I always enjoy going to different universities and speaking, and I appreciate the invitation. So I'm going to talk for a little bit about modern application of Darwinian theory to psychology. And I want to introduce, I'm not presuming that anyone has any background in evolution. I'm not sure what the state of education is in Michigan, but in Oklahoma, which is where I grew up, all the way until I was a senior in high school, the section, I took biology courses, but the sections on evolution were always blacked out. I mean, literally blacked out. And that's when I realized that's what I want to do. I want to do what they tell me not to do. Let me just give you a very brief overview of evolution, and of evolution by natural selection in particular. So you may or may not know that Charles Darwin, was not, in fact, the first to argue that species evolve. One of the first discussions of evolution predates Darwin by somewhere around 2,500 years, and this quote is attributed to Anaximander, a Greek philosopher. And this is, again, about 2,500 years ago, he noted, "In water the first animal arose, covered with spiny skin, and with the lapse of time some crawled onto dry land, and breaking off their skins in a short time they survived." The point really that I want to make is that Darwin wasn't the first to point out or to argue that species change, that species are not immutable. But he was, however, the first to identify a workable mechanism for evolution, and that mechanism is natural selection. And I'll talk very briefly about that in just a moment. Darwinian selection, which is often used to refer to natural selection, Darwinian selection is now certainly the foundation of all of biology. And in the past few decades, psychologists, anthropologists, criminologists, sociologists, a lot of people working within the life and social sciences have begun recognizing the value, the potential heuristic value of applying an evolutionary perspective to their work. So evolution by natural selection, in some ways it's incredibly simple. It's deceptively simple, I think, which is part of the reason it took someone up until, it was only 150 years ago, roughly, that Charles Darwin clearly articulated this theory of evolution by natural selection. Evolution by natural selection results when individuals vary in traits. Okay, there's a particular set of traits, and there are differences among individuals. When some of those traits are heritable, that is, they're passed from parent to offspring, and when individuals reproduce differently or differentially because of having those different heritable traits. Okay? Another way of saying this is that individuals can vary physiologically, psychologically, behaviorally. Due to these trait variations, some are better able to survive and reproduce. If those traits are heritable, that is, passed from parent to offspring, okay, then the population will become dominated by individuals with those successful traits. And it's really not any more complicated than that. Okay? Now, from the 1930s through the 1950s or so, advances in genetics aligned Darwin's theory with a workable account of inheritance. Okay? Before that, in fact, anybody who's read Darwin, actually it's incredibly readable, although there's some sort of Victorian English in there as well, but this is in 1859. But what Darwin actually proposed, he proposed this theory, but he actually did not know how traits passed from parent to offspring. And he recognized that. He said, I don't know how this works, but it's got to work. And he actually proposed a theory of what he called blending inheritance. Somehow, the stuff from one parent blended with the stuff from another parent, and it came out in the baby. So it wasn't actually until the 1930s or between the 1930s and 1950s where advances in genetics were aligned with Darwin's theory. This time period is referred to as the modern synthesis. This is where Darwinian selection was integrated with Mendelian genetics, or with particulate inheritance. So before then, really nobody knew exactly how this was working. They knew it had to work somehow, but they didn't know how. So with a proper understanding of inheritance, evolution by natural selection really took flight as an incredibly powerful explanatory model, as a way to explain nature. Following this time period, the modern synthesis, evolution by natural selection was extended to include what's now referred to as inclusive fitness theory. Okay? And this was actually originally presented by a biologist when he was a graduate student called William Hamilton, and this was in 1964, and it'll become a little more apparent why I'm telling you this in just one moment. Hamilton reasoned that selection operates not only in the way that Darwin talked about, so in terms of producing offspring, but also by virtue of what he called inclusive fitness. And all he meant here were the effects of the individual's actions on the reproductive success of genetic relatives. So if selection is operating at the level of the gene, okay, rather than the level of the individual, then genetic replication can occur by investing in sisters' kids, for example. So in short, a trait could be selected, according to Hamilton, according to this inclusive fitness model, if it causes the individual's genes to be replicated, okay, regardless of whether the individual directly produces offspring. Okay? So this addendum to natural selection, why we talk about this now or today, is that it produced a gene's eye view, okay, a gene's eye view of selection, and importantly could now explain, among other things, the evolution of altruistic behavior. In other words, helping at a cost to oneself. I mean, why would organisms, any organisms, humans, ground squirrels, snakes, why would they ever engage in altruism? They would and they could if selection was operating not at the level of the individual organism, but the level of the genes that build that organism, which are shared with its relatives. So, for example, there was a lot of work early on, this is back in the 1970s, on what are called 13-line ground squirrels. They look like little chipmunks, basically. And the thing that's interesting about these chipmunks is that, or these ground squirrels, is that they live in social communities, and one of them typically serves as an alarm caller. And so it'll constantly be scanning the environment for a potential predator, typically a hawk, for example. And when that hawk is seen, and hawks swoop down and pick off, one or more of the ground squirrels, when the alarm caller sees this, it'll rear up and make a shrieking call. And what happens is what you would expect. All the other members of the community bail out. They freak out and run to their underground burrows. And it is the case that very often the alarm caller is targeted by the predator. And so how could this happen? I mean, how could you get the evolution of a behavior that, if you're just looking at it at face value, it looks ridiculous? I mean, why would any one of these squirrels stand up and call, given that they're basically saying, here I am, pick me off? Well, according to Sherman and a lot of his colleagues working in the late 70s, it's the genes associated with producing alarm calling, okay? The genes associated with producing this alarm call, when a predator is sighted, can spread even at a cost to the alarm caller if the call is emitted in the presence of relatives, okay, and provides benefits to those relatives that exceed the cost to the caller. So what they found is that they could predict which ground squirrel would produce the alarm calls, and it was typically the ground squirrels that had the most close genetic relatives in the community. So this is what happens when you take a gene's eye perspective. You focus not on individual organisms, but on the genes that build those organisms. So all of this is to say that inclusive fitness theory was sort of an addendum that allowed for an explanation of altruistic behavior, which absolutely puzzled Darwin and many people at the time, and it was actually considered sort of a grand downfall of evolutionary theory, that it couldn't account for helping behavior or altruism. So inclusive fitness theory is today certainly the most important advance in our understanding of natural selection, and oftentimes when people refer to evolution by natural selection, they mean inclusive fitness theory. Or conversely, when people talk about inclusive fitness theory, they're typically referring to evolution by natural selection. Okay, so natural selection is the only mechanism that's capable of producing functional organization. It's the only mechanism by which complex adaptations can be built over evolutionary time. Okay, so natural selection acting on genetic variation produces three products. Okay, this is sort of a crash course in evolution. Adaptations, byproducts of adaptations, and noise. Okay? Adaptations are central to the study of evolution. Okay, these are small changes, small phenotypic changes that enhance the ability to survive and reproduce, and they accumulate in a species very gradually, okay, to build an adaptation. Okay? These adaptations, okay, are inherited, they develop reliably, they're species typical. That means that every member of the species has it. Okay, take the eye, for example. And they're selected for, they're built because they're efficient, reliable solutions to a particular adaptive problem that species has faced over its evolutionary history. Now, an adaptive problem is any challenge, okay, that recurred over a species' evolutionary history which affected its survival and reproduction. Okay, that's an adaptive problem. And adaptations are solutions that are built over time to those problems. So let me give you an example. So the heart, sweat production, and sexual arousal are adaptations. Okay, the heart is an anatomical adaptation, okay, that circulates our blood. Okay, it's beautifully designed in the sense of evolved by natural selection. It does, the heart itself is not good at detoxifying the body. It's not good at doing the sorts of things that the lungs do. It's very specialized in terms of sending blood throughout the body, circulating blood. Sweat production might be thought of as a physiological adaptation that regulates temperature. Okay, as you get warmer, you start to sweat more to cool off the body. Sexual arousal can be thought of as a psychological adaptation, okay, that motivates sexual behavior. Now, importantly, not all products of natural selection are adaptations. Okay? There are also byproducts of adaptations. Okay? These are traits that don't solve an adaptive problem, but are typically incidentally linked to an adaptation or piggyback on an adaptation. Now, here's the thing. Identifying byproducts of adaptations, okay, is just as rigorous a process as identifying adaptations. Because the thing is, if you hypothesize that a trait is a byproduct of some adaptation, you now have to explain the adaptation of which it is a byproduct. So here's a couple of examples. The human belly button, the human navel, okay, and the whiteness of bone might be thought of as byproducts of adaptations, namely of the umbilical cord. That's the adaptation. Okay? The fact that we have belly buttons is a byproduct of that. Belly buttons don't appear to solve any sort of survival problem or reproductive problem, but they're there because we have umbilical cords. The whiteness of bone, the fact that bone is white or whitish, we don't know any selective value or there's no apparent solution. There's no adaptive problem that's being solved by the fact that our bones are white. In fact, our bones appear white because they're loaded with calcium. Calcium, in fact, the inclusion of calcium to build bones increases the strength of bones and makes them more resistant to breaking. But the whiteness of bone is a byproduct of the high calcium content. Okay? A third product of evolution is what's often called noise or random variation. So we have adaptations, byproducts of adaptations, and noise or random variation. Noise doesn't solve any particular adaptive problem. Noise is typically produced by glitches or goofs during development, or by mutations. That's possible as well. But unlike a byproduct, noise is not linked to an adaptive aspect of a trait. Okay? Just continuing on with the belly button example. So you got the umbilical cord, which is the adaptation. The belly button itself might be the byproduct of an adaptation, and whether you're an innie or an outie might be thought of as random noise or variation. Okay, another example that someone gave to me, which I think is also potentially a really useful way to think about this. A light bulb can be thought of as, analogous to an adaptation, designed to produce light. Okay, so it's the production of light, which is the adaptation. The fact that light bulbs also give off heat is a byproduct of the adaptation. and the fact that light bulbs aren't perfect. So if you look at them real closely, you'll see little goofs. There'll be tiny little glitches in the outer surface. That might be thought of as noise or random variation. So the explicit application of Darwinian theory to the study of the information processing and behavior, okay, by which we mean psychology, okay, it has fundamentally changed psychology and continues to have an impact, moving very quickly through a lot of different areas of psychology, and there are new applications every day in thinking about psychology from an evolutionary perspective. And this is especially true for human psychology. And much of what I'll talk about presumes that we're talking about humans, but there's no reason why we couldn't have, an evolutionary rat psychology or an evolutionary bird psychology. I mean, anything that has a brain has a psychology. So let me speak more explicitly now about evolutionary psychology. So we know that natural selection built the human brain, okay, favoring those mechanisms that were better than alternatives at solving adaptive problems, the problems that our ancestors, all of our ancestors, faced and solved recurrently. The study of psychological adaptations is central to evolutionary psychology. Okay, now, because the focus of evolutionary psychology is on describing adaptations, just as the focus of evolutionary biology is typically on describing adaptations, some critics of evolutionary psychology have charged evolutionary psychologists with being what they call us hyper-adaptationists. We just sort of see adaptation everywhere. Now, hypothesizing that a trait is an adaptation, okay, making a case that, well, here's my hypothesis is that this is an adaptation. Okay, in fact, that's a heuristic that guides research. You don't just stop there. It guides research in an educated, heuristic way. Okay, and in fact, biologists have been conducting research this way for decades. Okay, very successfully, I might add. Now, I want to argue that all psychological theories are evolutionary. Okay, and the reason I think that is because all psychological theories imply the existence of psychological mechanisms. They imply the existence of something inside the head. And the only known scientific explanation for the functional organization, okay, for complex psychological mechanisms is evolution by natural selection. There is no scientific alternative. Okay, so all psychology is evolutionary psychology. Some psychology is just explicitly evolutionary. Okay, so our psychology is made up of what are referred to as psychological adaptations or psychological mechanisms, evolved psychological mechanisms. These are simply information processing devices, okay, that clearly are instantiated in or built in the brain, okay, but we're talking about the level of information processing, okay? These are information processing devices that were selected during our evolutionary history because that mechanism, whatever it is that we happen to be talking about, reliably produced behavior that solved some adaptive problem. Okay, it's there because it solved an adaptive problem recurrently for our ancestors. Evolved psychological mechanisms are described in terms of their specific input, decision rules, and output. Okay? Each mechanism evolved to attend to some narrow range of information, okay, specific to a particular adaptive problem. So an evolutionary psychologist, really this is in some ways just standard cognitive psychology, an evolutionary psychologist would argue we have as many evolved psychological mechanisms as our ancestors faced adaptive problems. So if you open up, the human body, you won't find a single giant organ that does everything. Okay? Instead, you'll find very specialized organs, each one of which solves a particular adaptive problem. The liver detoxifies the body. The liver cannot be made to function as a workable heart. Okay? That's a separate adaptation. That's the heart. The heart circulates blood and does not do well if pushed into a detoxifying sort of function. The same has been argued to be true of our psychology. It's made up of these evolved psychological mechanisms, multiple evolved mechanisms. The information that the organism receives signals that the adaptive problem is being confronted. That information is transformed into some sort of output, behavior, or physiological activity or input into another mechanism by some decision rule, some if-then procedure. Okay? Now, because evolution is gradual, okay, it's very slow, and you're talking about accumulations of very almost imperceptible changes over millions of years, our minds are built for the environments in which we spent most of our evolutionary history, okay, and of which they are a product. Okay? So what this means is that our minds are not built to solve novel problems of the modern environment, okay, but instead to solve problems of our evolutionary past. So let me give you a couple of examples of some of the consequences of what are called evolutionary time lags. So if you look at, you can look at fears around the world. What do people fear? Okay, and we can contrast reported fears of what evolutionary psychologists would call ancestral threats, and contrast those with modern threats. So basically, around the world, there are a collection of things that people fear. I bet you guys could name them right here. So does anybody have any ideas? What are the things that people all over the world? That's one. Spiders. The dark. Somebody said snakes. Snakes. Yep. Any others? In the sense of, yeah, that does vary. That doesn't tend to be recognized. Or social evaluation, yeah, sort of comes up, yeah, in that sense. So public speaking will be part of that for sure. Yeah, yeah, it might be part of that, fear of loss. So it's the things, it's the sorts of, one other one is enclosed spaces. Heights, strangers, yeah. Somebody said strangers. Strangers is another one. Snakes. I mean, most of us, if you look at the frequency of reported fear of spiders, okay, very few of us today in the modern environment are actually at grave risk of death by spider. Okay? We have these fears nevertheless. What most of us should be really fearful of are cars, for example, given that 1 in 6 of us, or will get into a terrible accident sometime in the next year. Not saying you're going to die, but you appreciate that the risk of death by an automobile is extraordinarily higher than the risk of death by a spider bite. But our minds are built for evolutionary environments. Okay? They're built for environments that our ancestors successfully navigated. Okay? And so it's very easy, if you don't have a fear of spiders, it's very easy to condition a fear of spiders. It's very difficult to condition a fear of evolutionarily novel objects like, a cigarette, for example, or an automobile. Okay? So the point is that clinicians don't spend a huge amount of time, well, let me change that. Spend more time dealing with fears of what we would call ancestral threats, okay, and less time dealing with fears of what we would call modern threats, okay, because of an evolutionary time lag. So our minds are built for ancestral environments that are sometimes quite different from our modern environments. Another example of this evolutionary time lag are our preferences for sugar and fat. We have intense preferences for sugar and fat, for foods that are high in sugar and fat, basically. The problem is, our minds weren't built for environments in which, there's a McDonald's on every corner. And so one of the problems we have today are problems surrounding obesity and a variety of health concerns surrounding overeating and ingesting too much sugar and too much fat. Our ancestors are those early humans whose psychology included these preferences, because stumbling upon, ripe fruit, who knows when the next time you'll stumble upon it. And so it made sense to eat what you could then. They're high calorie, high fat, wonderful sources of nutrition, just not every single day. Okay? So our modern behavior then is best understood in the context of what's often called our environment of evolutionary adaptedness. This environment is not a place or time. Okay? It's not a specific place or time, but it's a composite of selection pressures, okay, operating on a species. Each adaptation, each individual adaptation has its own unique environment of evolutionary adaptation, or adaptedness, okay, but there's of course likely to be a lot of overlap, okay, between these evolutionary environments. evolutionary psychologists often use the Pleistocene. They refer to the Pleistocene as the human environment of evolutionary adaptedness, because that's the period, which is about 1.8 to 0.01 million years ago, which includes many of the selective periods for many of the adaptations that define Homo sapiens sapiens, that is, modern humans. So although our evolutionary past is not available, we obviously can't directly observe it, a description of adaptations allows us to make inferences about our evolutionary past. Okay, to the extent that we can describe how our minds are built and what they're designed to do, what they're for. That gives us a window into what built them, and therefore a window into our evolutionary past. Now, some adaptations provide unequivocal information, okay, about our ancestral past. So, for example, our minds are littered with adaptations that have to do with navigating the social world. Who said what to whom, and who did that to who, and all over the world, people gossip and they talk about friends and enemies and who has your back, who doesn't have your back. That suggests, it doesn't prove anything, but it suggests very strongly that our ancestors also were a social species. Okay? Now, there's good evidence for human male mechanisms, psychological mechanisms associated with thwarting or stopping a partner's infidelity. What that tells us is that female infidelity was a feature of our evolutionary past. Conversely, we could also do this. We could look at that. We could flip it so that female mechanisms associated with thwarting a partner's infidelity indicates or suggests that male infidelity was a feature of our evolutionary history. Again, it doesn't prove it, but it's a piece of data, okay, that helps to describe what our evolutionary history was like. Various other adaptations, however, are less clearly indicative of our ancestral past. So, for example, we all have this mechanism in our middle ear that reduces sound intensity, okay, by 30 decibels in something like 50 milliseconds. And this is referred to as the attenuation reflex. This reflex acts by contracting muscles, okay, that pull the stirrup away from the cochlea, preventing strong vibrations from damaging the inner ear. Now, this reflex meets a variety of criteria for an adaptation. Okay? It reliably develops, it's species typical, but it's not obvious what selection pressure designed it. Why do we have this? Okay, what is the function? What specific noises might our ancestors have recurrently heard, okay, over evolutionary time that could have caused the evolution of this mechanism? Well, the fact that these muscles contract just as we are about to speak suggests that our own voice, okay, might have selected for this adaptation. And again, it doesn't prove anything, but it suggests it. And in fact, sound attenuation is greater at lower frequencies, in particular in the range of human speech, suggesting once again that vocalization or vocalizing was part of our evolutionary past. Okay? So by describing adaptations, we can characterize aspects of our evolutionary environment. Okay? This is referred to as an inductive approach. Okay? Moving from data to theory. You've got data, and you're developing some theory to account for these data. That's referred to as an inductive approach. Oops, dang it. Uh-oh. Oh, there. Evolutionary psychologists, like any standard science paradigm, also use what's called a deductive approach. Okay? This is moving from theory to data. You've got some theory, and it guides you to collect a certain set of data to test that theory. In this case, evolutionary psychologists, using this approach, make predictions derived from hypotheses, okay, that are based on what are called middle-level theories, and then they collect the data to test it. Okay? Test those predictions. So, for example, David Buss and his colleagues, working now over like 25 years ago, tested the hypothesis that men and women will differ in their reactions to a partner's sexual infidelity and emotional infidelity. They predicted this, in short, because human males, but not human females, recurrently face the adaptive problem of paternity uncertainty. Okay, so our ancestors were never certain, our male ancestors were never certain that any offspring their partner produced were in fact genetically their own. There's not a comparable problem of maternity uncertainty, for reasons that hopefully are clear once you just think about it for a moment. Now, of course, today we can do paternity testing with incredible reliability, but I think we can all appreciate that that's a very novel sort of invention. But the argument is that our male ancestors were at greater risk of incurring costs, reproductive costs associated with a partner's sexual infidelity than with a partner's emotional infidelity. If you pull these apart like this, women, on the other hand, ancestral women, they didn't risk maternity uncertainty, but they did risk the diversion of any resources that their partner provided, social, emotional, financial, economic, political, to another woman and to another woman's child or children. So the prediction here, despite 100 years worth of work on jealousy, showing that the sexes don't differ, what they suggested is we will find a difference if we separate out sexual infidelity and emotional infidelity. Okay, and that's precisely what they found using self-report, partner report. They also hooked them up to psychophysiological measures. So, and then they asked them to imagine their partner having sex with someone else or falling in love with someone else. So men's heart rate jumped up the equivalent of slamming back 5 cups of coffee in response to the sexual infidelity and relative to their response to imagining a partner's emotional infidelity. The reverse was true for women. It was the emotional infidelity that was much more upsetting for them than the sexual infidelity. Okay, and again, I don't mean to suggest that either sex is fine with one type of infidelity, but there is a very strong sex difference, and this has now been replicated in, I think, 62 different cultures. So it's not something peculiar to the Western world. So, here's the thing. They didn't just happen to collect the right data or happen to collect, the appropriate data, analyze that data, and then develop some post hoc explanation. They made a very clear, straightforward prediction about sex differences that was guided heuristically by an appreciation of the fact of evolution by natural selection. Okay, and the sorts of the sex-differentiated adaptive problems that humans are likely to have faced. So another point here is that claims of adaptations are tentative until the proposed adaptation has survived rigorous hypothesis testing. Okay, to just declare something an adaptation is poor science. Okay, that's poor. I mean, you might generate a hypothesis, but then you have to go out and collect the data, okay, and see how it maps on to what you thought. Okay, so the modern application of Darwinian theory to human psychology has really opened up a variety of new lines of research, and in many ways it's shaken up a variety of old topics in psychology. Okay, let me just give you a couple of examples. So the recognition that female infidelity, okay, was a recurrent feature of our evolutionary past has inspired new research in human mating, guided by what's known as sperm competition theory. This is one example. So sperm competition theory is a very well-established theory within biology that has 40 years worth of work looking at the behavior and the physiology of insects and birds and mammals and primates even, but very, very little work on humans. Nevertheless, some evolutionary psychologists have recently been applying sperm competition theory to humans to try to understand whether we might also see or be able to document some evidence of an evolutionary history of sperm competition. And just to be clear here, I know it sounds weird. It sounded weird to me too when I first started reading about it. But sperm competition occurs when the sperm of 2 or more males occupy the reproductive tract of a female and compete to fertilize her egg or eggs. Okay, it's inevitable. When you have the sperm from different males, they will compete. Okay? They can't both fertilize the egg. Now, psychological, physiological, and even genetic evidence indicates that men have evolved solutions, that human males have evolved solutions to combat the adaptive problems of sperm competition. Let me just give you one example. This is from our lab now, about 15 years ago or so, 14, something like that. So we found that men who spent more time, we studied couples, and we found that these are couples involved in long-term relationships of about 4 years on average. And we found that men who spent more time apart from their partner, okay, since they last had sex, okay, so they spent a larger proportion of their time physically apart from their partner since they last had sex, okay, and therefore facing greater risk of sperm competition due to female infidelity. I mean, if a woman is going to be unfaithful, and similarly for men, but we're talking about male psychology for the moment, if a woman is going to be unfaithful, she's more likely to be unfaithful when she's not with her partner than when she is. So it's a very straightforward way. It's a proxy for risk of infidelity. So men who spent more time apart from their partner since last sex, therefore men who face greater risk of sperm competition due to the risk of female infidelity, report that their partners are more sexually attractive, more physically attractive. They're more interested in having sex with them sooner rather than later. They think that other men think that their partners are more attractive, and that's controlling for time since last sex. It's not just time since last sex. It's a proportion of time spent apart since last sex. And these results map on very predictably to the work on other socially monogamous species where infidelities of either partner occur, notably in birds, where something close to 90% of birds are socially monogamous. That is, they pair up over multiple breeding seasons, but they also have infidelities, both the male and the female. So without an evolutionary, let me back up. So these perceptual changes, perceiving that other men think that his partner is more attractive, for example, or being more urgently interested in having sex, these sorts of perceptual changes motivate men to pursue sex with their partner, thereby entering their sperm into competition with any rival sperm that might be there, ancestrally speaking. So without an evolutionary perspective, this line of research may well have been missed. Now, an evolutionary perspective has motivated rethinking old topics as well. Okay? So there's decades worth of non-evolutionary psychological research that argues that people encode race automatically. Okay, that it's an automatic occurrence. People automatically encode, whether someone is of this race or that race. Robert Kurzban and his colleagues, these are evolutionary psychologists, they proposed that our psychology did not evolve to encode race. Okay, in fact, there's good evidence that most of our evolutionary history is unlikely to have been characterized by interactions with people who look very different from us, okay, or have different skin color. I mean, basically, you interact with people who look pretty much like you. Okay, so that's the argument that it's unlikely that race is likely to be part of our evolutionary history, that interactions with other race individuals. They argued instead that the fact that people do appear to encode race is a byproduct of adaptations for detecting coalitional allies or potential friends. Okay? We use race as a proxy in the modern world. So by varying cues of coalitional affiliation and race so that they didn't co-occur together, they found very clearly that the effects, in the title of this particular paper was, "Can Race Be Erased?" And yes, indeed, if you disallow the use of race as some sort of coalitional cue, then or if you make it irrelevant to deciding who's on your team, who's not on your team, then people immediately let it go. Okay, and they'll focus, they will lock in. Humans are remarkably social, and it's very easy for us to pick out us versus them. But people will let go of race very quickly, as long as you give them something else, okay, the other team versus our team. I suggest that a good deal of research on prejudice and discrimination will benefit from this sort of research, or could benefit. So, in terms of the future of evolutionary psychology, although this approach to psychology is young, okay, evolutionary psychology's impact is already permeating psychology. Now there are subdisciplines of evolutionary psychology. There's evolutionary clinical psychology, evolutionary social psychology, evolutionary cultural psychology. One of the biggest movements now within the field is integrating women's studies with evolutionary psychology. So there are several researchers, there are conferences now on evolutionary feminism, evolutionary women's studies, and gender studies. So it's, there's really no sort of line in the sand where here evolutionary psychologists, are forbidden. Well, people may draw those lines, but evolutionary psychologists just keep pushing. It's been applied to a variety of fields, medicine. The University of Michigan actually has the first, it's actually been in existence for something like 25 years, the first program in Darwinian psychiatry. So it's the application of psychiatry with an explicitly evolutionary perspective. Then there are several law programs, notably at Vanderbilt and Arizona State, where you can focus on evolutionary perspectives on law. Okay. Right, so evolutionary psychology's current utility and bright future are also evident in the fact that the number of research publications guided by an evolutionary perspective really has been exploding. That's not all good, of course. That means there's probably more junk out there too. But I mean, it's a field that's really growing, and there are new journals that are now available. Societies, academic societies are growing very quickly. Some have even suggested that in the future, there may be sort of a psychological equivalent to a Gray's Anatomy. You know, if you flip through it, you can see the human body has this, there's the liver, there's this, there's that. Something that describes every person. Some people have argued that we'll have something similar to Gray's Anatomy, but for psychology. Okay, cataloging all evolved psychological mechanisms, their information processing features, and their neural substrates. I mean, that may happen, but it's not going to be for a very, very, very long time. Okay, let me conclude with a couple of comments. Because our brain owes its functional organization to natural evolutionary processes, an evolutionary approach is a reasonable framework. Okay? In fact, I'd argue it's the only useful framework on which to base all psychological theories. Evolutionary psychological theories specify the adaptive problems that the mechanisms were designed to solve, thereby providing some information about the likely design features, okay, its bits and parts. Now, it is possible, of course, to do research in psychology with very little knowledge of evolution and with no explicit application of evolution. I mean, this is what many psychologists do, probably most. But without an evolutionary perspective, you know, my take on it is that psychology appears to be, and in fact, well, certainly appears to be, sort of a disparate, disconnected set of mini fields. And there's no consistent thread running through if you battle back an evolutionary perspective. Darwin's theory of evolution by natural selection provides a meta-theoretical framework, an overarching way to think about the structure of the human mind, okay, according to which all of psychology can be organized. And I want to leave you with a quote from Charles Darwin, who many people have argued was the first evolutionary psychologist. And this is on the very last page of his 1859 book on the origin of species. So he says, "In the distant future, I see open fields for far more important researches. Psychology will be based on a new foundation, that of the necessary acquirement of each mental power and capacity by gradation. Light will be thrown on the origin of man." Thank you very much for your time. I'd be happy to take questions. Yeah.
What do you say to people who are religious or argue against theory of evolution?
I would say, let me speak very carefully, I would say they're ignorant. Not stupid, because I come from Oklahoma, where I've got a lot of smart relatives who are simply ignorant. I'm ignorant about lots of stuff, about most of baseball. I'm pretty good on football, but I'm not real clear on a lot of the details. Yes, I would say it's an unfortunate circumstance that so many millions of people, particularly in the United States, are ignorant of evolution by natural selection. It is a fact, as factual as gravity. I mean, it is, after all, still the theory of gravity. But, of course, we have no alternative. So, yeah, and in fact, one of the most interesting areas within evolutionary psychology these days is on the study of religion and religious beliefs. How is it that religious beliefs come to be? I mean, how is it that people often will center their lives around religious beliefs? I mean, not everyone is religious, of course, but religion is a very important part of people's lives. So, yeah, I mean, it's, I just try to, treat people with respect and tell them that, arguing that Darwin's theory of evolution by natural selection does not account for complex life is like saying that the earth is flat. It's just raw ignorance. Yeah. Yeah.
Sure, but because when people think about evolutionary psychology,
Yep.
they tend to think about biology.
Sure.
Where in psychology, there's a whole body of research that looks at the social, the needs of the social, and thus evolution. Our evolution as a species also connects to this motivation. There's really a survival need to be social.
Sure.
And I think even when you connect that to socioeconomic status, it's
Sure. Yeah. So, I mean, no doubt about it that a huge number of evolved mechanisms of the mind, the human mind, are dedicated to social sorts of issues. I mean, in many ways, that's true of many social species, where there's very close attention to who's up, who's down, why are they up, why are they down, how can you pick out who's up and who's down. But that, yeah, in many ways, I certainly appreciate the argument that in humans, that's sort of spun out to a very, very intense level, a level that arguably isn't seen in any other social species. And certainly, I think the answer is likely to be somewhere in the field of evolutionary cultural psychology, or understanding that we have this evolved, we have this set of evolved mechanisms that is attentive to many things, including cues to social status, cues to who has resources, and humans all over the world care and are interested in who's up and who's down. Now, among the Ache of Paraguay, they might be interested in who has, more of the silvery feathers, and how did they get them? Versus here, we're more concerned about who has more money in their bank account, for example. So the actual, the material goods vary, of course, but it's the same basic psychology that's operating. So yeah, the other thing that your question reminds me is that, much of what we call evolutionary psychology today really got its start in social psychology and social and personality psychology, and in particular in intimate and personal relationships. So a lot of the early work in evolutionary psychology focused on mate preferences and interest in prospective partners, and how do people decide who they want to have sex with, who they want to marry. And so a lot of that early work was in mating, which is sort of a subset of social issues. So yeah, I hope I addressed some of that. Yeah. Okay. Yes?
Near the beginning, you were talking about the ground squirrels and altruism.
Yes, yeah.
How do you explain altruism during time?
It's a great question, and I think there are several potential answers. So helping a complete stranger, for example. Why do people, let's just take humans in particular, why do humans help total strangers, or someone who's otherwise not genetically related? There are a lot of potential explanations, and it may vary as a function of whether you're talking about friends, close friends, for example. There's a lot of work on what's known as reciprocal altruism. So I scratch my back and you'll scratch mine. Wait, no, I scratch your back, you scratch mine. Tit for tat. Which is not exclusive to humans, of course. Other species do this as well. So some of our helping behaviors can be explained, or might be explained, with reference to reciprocal altruism, trading favors over time. Some of it also may be explained by residing in an environment that is very different in many ways from ancestral environments. So today, giving money, for example, to a stranger who's on the street and is asking for money. What may be going on there, some have argued, is that it's basically parasitizing or taking advantage of a psychology that evolved to respond to people who were likely to be your relatives over evolutionary history. To find ourselves surrounded by non-relatives is relatively bizarre. If you think about the way most people live their lives around the world, they still live them very close to their close relatives. They don't, sort of disperse like we do in the modern Western world. So some people have argued that helping strangers is, in many ways, it's an error. It's a wonderful error, but it's an error. It's a goof. It's a glitch. And that might help to explain why when people ask for things, people will often use, and I don't think they're doing this consciously, they'll use relationship sort of labels. Brother, can you spare a dime? And often, in fact, a lot of religions around the world use these sorts of relatedness kinds of terms: father, sister, brother. And the same is true in militaries around the world. There's often, a sort of a sense of, or an attempt to sort of generate a sense of familial relatedness, to sort of tap into that desire to help a brother, a sister, a father. So I don't think there's one answer. But certainly, I think it's fascinating. Yeah, it's a fascinating question that one of you might solve. Yeah. Yes.
Would you think that some people may be more involved on an evolutionary psychological standpoint? If I'm trying to make a difference between biological, like evolution being Darwinism, like people would be more empathetical and they would be more involved on a social standpoint. Would you say that it would be more proportionate to evolutionary, like biological evolutionary, or is it not proportionate to other?
Well, so you're saying, so you're talking about not literally more evolved.
Yes, that's correct.
You're not talking about that, right? You're not talking about that. Okay, you're saying might there be differences in terms of cultural evolution? Is that what you're talking about?
I think if a person who's 20 today and my age right now, would they be more evolved psychologically because of their empathetical or social skills that would be superior to mine or mine superior to theirs? Do you think that that is a possible, would that be a realistic situation?
Yeah, I mean, the sense in which I think you're dead on is, I think it's a different use of evolve. So in other words, there's very good arguments that there's been incredible moral progress among humans just over the last 100 years, never mind the last 1,000 years. I mean, today we don't celebrate, we don't go out and have a great time by watching, cat burning, which our ancestors of just a couple hundred years ago did. I mean, that was part of what you did. You go out on a Sunday and put cats in a bag and light them on fire. Yay! Today we recognize that that's cruel. And we appreciate that cats also are sentient beings who can experience pain. And we also, of course, we no longer support slavery. I mean, that's something that, again, not that long ago. In fact, the last country, in 1983, was the last country where slavery was legal. So there's been tremendous moral progress, but it's the same psychology. So our very close relatives of just a couple hundred years ago who engaged in cat burning and breaking at the wheel and public executions. I mean, these are things that they weren't any less evolved. There's every indication that we share the same psychology. What's happened has been moral progress, progress in appreciation for, sort of a basic level of suffering, and that non-humans can suffer, and that people that look, maybe our skin is a different color, but they nevertheless can experience pain and suffering. So it's a really interesting question. That's another area that has absolutely just caught fire within evolutionary psychology, is evolutionary moral psychology. So trying to understand the evolution of morality and how is it, what's the psychology that supports morality? And this, incidentally, is despite the fact that Francis Collins, who's the head of the NIH, the largest scientific organization in the world, has sort of declared by fiat that morality is off limits. It didn't evolve, and it was sort of poofed into existence by his particular God. So it's controversial in some sense, but not legitimately controversial. But it's an area where people have been afraid to do research because there's a lot of, because some people are upset by that. Sort of like where sex differences were about 20 years ago, 25 years ago. It was considered like super taboo to study sex differences. Today, I mean, it's perfectly legitimate to ask whether the sexes differ. I mean, I don't mean to be naive or sound naive. I know that some people still get upset by that, but I remember giving talks at Michigan in 1992, 93, where people were like irate and stormed out, were crying, were screaming at me because I dared ask whether the sexes differed. It's not true anymore, but it still can be true for some questions about morality sometimes, and questions about religious beliefs and understanding the evolutionary history of the psychology that motivates and generates religious belief. Yeah.
Do you think that there may be an intelligent design for evolutionary psychology? I know Darwinian evolution by natural selection discusses that the nucleus of the cell doesn't come from the mitochondria of the cell. Is there a parallel argument for an intelligent design?
Well, it depends on what you mean. I mean, natural selection is, in some sense, it produces adaptations that appear for all the world to be not just intelligently designed, but beautifully designed. At the same time, psychology is littered with all sorts of giveaways, just like our bodies are littered with all sorts of giveaways that intelligent design, that is in terms of some sort of supreme being creating our bodies, it doesn't map on well in the sense that there are a variety of glitches in our bodies and in our minds that reveal that, there may be a designer, but he or she or it wasn't very intelligent, installing the machinery of our eyes in backwards. So now we have to see through the rods and cones, and then we have a blind spot as the nerves go back to the brain. And there are other sorts of issues like that. So the thing is, you don't need it. You don't need to pose an intelligent designer to explain the evolved machinery of the human body. And then, of course, if you do, then, some would argue that, now you've replaced, you're using something that's got to be at least as complicated as that which you're trying to explain, and so you just push the question back. So where did God come from? Where did that intelligent designer come from? Well, he's always been there. Oh, okay, then. You're basically saying, please excuse me from the conversation. So, yeah. Sure. That's a really interesting question. I certainly are. Now there are so many more people. If you're talking about just about humans, really what you have to look at is, the selection pressure itself and the intensity of the selection pressure. And one could make an argument that the same selection pressures, for example, a variety of diseases today, which could function as selection pressures, have much more intense consequences today in terms of the number of lives taken, for example. And so, yes, I don't know of any works explicitly on that, but the speed with which evolution occurs certainly, by definition, can be ramped up by you're having, let me just put it crassly, there are more opportunities for bad things to happen, but also for the occasional productive mutation, or a mutation that actually provides a benefit. Yeah, in terms of natural history, sort of by definition, only some traits will make it through the sieve. Only some shakes through, and most traits will not, and therefore most individuals will not. So in a very real sense, evolution by natural selection, sort of presumes and operates on an unconscionable amount of suffering. That's true not just for humans, but for all organisms. Yeah. Sure. Mm-hmm.
It's exponentially faster today. Heart disease is almost non-existent in the modern world anyways, to the level that it was, because heart transplants and open heart surgery is, commonplace.
Sure, yeah. So, it's a leading cause of death, yeah. Yeah. But what happens is, there's a shifting of ultimately what kills you, for example. Or just another example is, so today, we have the ability for infants that are born at like 24 weeks now, can survive. They need intense help and so forth. But a few years ago, infants that weren't at 30 weeks, didn't have a shot. And so, yeah, I mean, what it means is that you're shifting the selective target just a little bit. And there are people who, wring their hands over this stuff. Over what are we doing? What are we doing? I mean, we're altering the gene pool. Yeah, we are altering the gene pool, and people do all sorts of things. But whether that's right or wrong, I think, is a separate question. Yeah, so at any rate, I think certainly, given that there are more opportunities, more tickets in the lottery, so to speak, if you think about the number of people today, and while I totally, of course, absolutely it's the case that in the modern Western world, we have medical technology that's, allows 26-week-old premature infants to survive. But one of the things to keep in mind is that, we live an insanely charmed life. So right now, there's, 20,000 children die every single day in sub-Saharan Africa for totally preventable diseases and from starvation. Every day. So we live in an extremely strange world where people not only don't starve to death generally, but they actually do quite well and make it to be, 70 or 80. The average lifespan, the life expectancy in sub-Saharan Africa is something like 28, and you're like super old if you made it to that point. So yeah, it's, I know it's, I do the same thing. We do have remarkable technology now, including selecting characteristics of our children. That's another technology that's emerged where people can go into sperm banks, for example, and actually say, I want my child to have this kind of hair, and so that's also, a novel sort of situation. Other comments or questions?
So, kind of going off that, it's not necessarily
Yeah.
psych-related.
Sure.
And correct me if I'm wrong, but evolution states that like living beings and humans never sort of develop one to the next. There are links that show this becomes that.
Sure.
For instance, primates to humans.
Well, we are primates. Yeah.
Okay. So, but why, and maybe there is, and I just don't know of it, but it seems that things are continually evolving, and so why, for instance, does it appear that the human race has sort of come to a standstill in development? Like people in third world countries, why haven't they evolved into something that can survive their
Sure. That's a great question. It does seem that way in some sense, but we actually know that's not the case. So we know that there have been very rapid evolutionary changes, rapid in the sense of over the last several thousand years. For example, the evolution of some of you may sort of have to deal with lactose intolerance, for example. People who are lactose intolerant had ancestors that were not domesticating animals. Those of us whose ancestors were involved in animal domestication, in short, drank milk from these animals and basically evolved an ability to process these foods. And so that, in some sense, is a difference between, among a group of people. That's an evolutionary change, a change in gene frequencies. That's all that evolution means. It refers to a change in gene frequencies. But those aren't changes at the level of basic psychology. So I would argue that humans all over the world are psychologically identical in terms of the basic structure, in the same way that we're biologically identical, in that we're all members of the same species. I don't mean to say that we're all clones, but a human is a human is a human. Who knows what the future holds? We don't know what the future holds. We know that we're one of at least 5 species of humans. We're the only one left, Homo sapiens sapiens. But it wasn't, 30,000 years ago or so, we shared the Earth with another species of humans, Homo sapien or Homo Neanderthals, which were a species of humans. So, evolution by natural selection doesn't stop. To the extent that there are individual differences, if you have a group of individuals, to the extent that they differ, some of those differences are, cause greater survival or greater reproduction, and some of those differences are heritable. Evolution by natural selection will occur. It will churn on. And it may be just the fact that not enough time has passed from the time that, it's only been something like, 5-6 million years since we diverged from chimpanzees. And that's from chimpanzees. So imagine thinking about just human history. You're talking about just a few 100,000 years. And so we might not anticipate a huge number of changes. But unless we're all clones, which clearly we're not, then evolution by natural selection is occurring. But nobody knows sort of how it will turn out. That's a very good question, though.
Well, if there's no other questions, I want to again thank you for coming.
Yes, thank you.